Okay, so I'm going to be solving my problems with my apprentice, which is my dad. And so I'm going to teach him about binomial probability. Okay, so our problem is Sally is going to bat 5 times in her softball game. She has an 80% chance, or P equals 0.8, of hitting the ball. What is the probability Sally will hit the ball at most one time? And what is the probability Sally will hit the first ball but miss the other 4? Are the two problems we're going to be solving. I will be solving the first one, and my apprentice will be solving the second one. So solving for problem 1. So the order does not matter in the first problem since it doesn't ask the probability Sally will hit the ball in a specific order. As we can see in problem 1, it's just asking what the probability is she's going to hit the ball at most one time. And in the second problem, it's asking what is the probability she'll hit the first ball but miss the other 4. So since this one isn't asking for a specific combination, that's going to affect our problem later. So it's important to notice that. So the problem is asking what is the probability Sally will hit the ball at most one time. So Sally can either hit the ball 0 or 1 time. And there are multiple ways Sally can hit the ball 0 or 1 time because, again, the problem doesn't specify a specific order. So therefore, we need to solve each potential way Sally can hit the ball separately. So first, we're going to refer to the binomial probability formula, NCR times p to the power of r times 1 minus p to the power of n minus r, where n is the total number of attempts, p is the probability of a successful attempt, and r is the selected amount of successful attempts. So the binomial probability formula works because unless the order is unspecified, there are multiple ways to get successful attempts from a total number of attempts. So we're going to use NCR to find out how many ways Sally can get R, 0 or 1 hit out of N, 5 attempts. So that's why we include NCR in our formula, because there's multiple ways, like in this problem, Sally can hit the ball. So we need to calculate that. We're going to use p to the power of r because we can find the probability Sally will hit the ball r amount of times by multiplying her chances of hitting it, 0.8. And lastly, we're going to use 1 minus p to the power of n minus r. So because we then need to find the probability Sally will miss the ball, 1 minus 0.8, and then multiply it by the amount of times she will miss it, which is 0, or 5 minus 0, or 1. So we're going to solve. So solving, Sally will hit the ball 0 times. So we're going to write out our binomial formula. So we're solving for 0, so I just put P 0 because what's the probability she's going to miss all of them? And we put 5C 0 because she's going to hit the ball 5 times, but she's going to miss all of them. So our successful amount of attempts is going to be 0. 0.8 to the power of 0 because, once again, she's going to miss all of them. She's going to have no successful attempts. And then we're going to do 1 minus 0.8 to the power of 5 minus 0 because she's going to miss the ball all time, like every time. So we need to find out what's the probability she'll miss it 5 times. Then you should end up with something like this. And then our answer, or your answer, should be 0.00032. Or if you want to convert it to percentage, it's going to be about 0.032%. So the probability is very small for that problem. All right, next part, we're going to calculate the probability Sally will, I don't know what happened, I apologize. Sally will hit the ball 1 time. Just ignore that, I apologize. So once again, we're going to plug in our binomial formula, which is p to the power of r equals NCR times p to the power of r times 1 minus p to the power of n minus r. And once again, we're going to plug in our numbers. So Sally will hit the ball 1 time. She's still having 5 total attempts, we're trying to find out the probability of 1 successful attempt. So we're going to use 0.8 to the power of 1 because we're going to find out the probability she's going to hit the ball once. And then we're going to find out the probability that she's going to miss the ball 4 other times. So you should end up with something like this. And then you will get this. So the chances are still pretty small. It is 0.0064, or in percentages, it's going to be about 0.64%. So again, very small. Then to find out, let's scroll to the top to our first problem. What is the probability Sally will hit the ball at most 1 time? We're going to add our 2 probabilities. So we're going to add our chances of her missing the ball every time. We're going to add the probability of her hitting the ball 1 time because it's asking for at most. So she can miss the ball all times, or she can hit the ball once because it's at most. Like I said, we need to add. So once we add them, we should get 0.00672. If you convert it to percentage, it's going to be 0.672%. So the probability Sally will hit the ball at most 1 time is 0.00672. So now I'm going to teach my dad about binomial probability, and he's going to solve the second part of the problem. So my apprentice, as we can see in his work, he used the binomial probability formula. And since this problem is asking for a specific order, he put 5C5, which is correct, and that's going to end up being 1 because it's asking for a specific combination. And then he put 0.8 to the power of 1 because the problem is asking what is the chance she's going to hit the first ball, and she has a 0.8% chance of hitting the first ball, so 0.8 to the power of 1. And then he's asked, but misses the other 4. So he put 1 minus 0.8 to the power of 5 minus 1, which is 0.2 to the power of 4, which is correct because Sally's going to miss 4 balls, and she has a 0.2% probability of missing a ball. So that ends up being 0.8 times 0.0016, which ends up being 0.00128. And he converted to percentages, which is 0.128%.